So in a minute, I'm going to turn back your quizzes, but first we're going to practice for a little quiz we're going to take tomorrow. So this has to do with what we learned yesterday. So I didn't write out the whole problem, but the whole problem says this point is on the terminal side of an angle in standard position. Find the 6 functions for that angle. So if you remember from yesterday, we drew a picture of the angle. Now the point is 4, -1, so which quadrant will that be in? The 4th, right? So we come over 4 and down 1. Here's the origin. So the point 4, -1 is right 4 and down 1. And remember that when you draw a triangle, so your point might be in a different quadrant tomorrow. And when you draw it, if it's in quadrant 1, it looks like that. If it's in quadrant 2, it looks like that. 3, it looks like this. And 4, it looks like that. Right? All together, they make a butterfly bow tie. Make sure that the picture you're drawing is one of those. All right, so now what happens? We've got our picture drawn, plotted the point 4, -1. Now what happens? Well, we have the adjacent side and the opposite side. So we could actually fill in some of this, but we can't fill it all in until we also have the hypotenuse, right? So what do I need to do to get the hypotenuse? Pythagorean theorem. And half of you, a full half of you, messed up your Pythagorean theorem yesterday. That's sort of embarrassing, right? You know the Pythagorean theorem is side squared plus side squared equals hypotenuse squared. So 16 plus 1 equals h squared, so h squared equals 17. So this is the square root of 17. So now we have all the sides. So now it's just a matter of having things memorized. Here we go. What's the sign? Opposite over hypotenuse, which in our picture is -1 over root 17.
Good morning, Cathedral. God's peace be with you on this Tuesday morning. The moral quote of today is, respectfully make your views known. Ask for God's help to see whether your perspective is reasonable. I want to take a brief moment to introduce our guests today. Today joining us, we have Maren Brooks, Drew Douglas, Mackenzie Elaine, Sarah Ewing, Dylan Herget, George Madden, Aaron Marcoux, Riaja Moore Tyler, Daniel Parra, Josh Puno, Anika Sood, Hayden Sylvia, and Anne-Marie Kramer. Thank you so much for joining us today, and I hope you get as much out of your visit here as we do from your presence. Well, Cathedral, you're on a journey to staying put in this life, and you're on a journey to heaven in the next. If you could accept the full ramifications of that, I would have no other advice to give you. If I could accept the full ramifications of that, I would never sin again. But we are on as much of a journey just trying to understand this charge as to live it. So we must plod, working slowly, carefully, intentionally, catching ourselves when we sin and fall back to our baser self. When we let the love of this world interfere with the love of the eternal. So my advice to you is this. There is something tugging you away from your journey, your charge. There is some past hurt, some fear, some longing, some comfort that you're afraid to let go of, to accept, to forgive yourself for. I know this because I am very much the same way. I gather my past failings around me like bricks of a castle. Evidence that I am not meant for sainthood, not me, it must be someone else. I am reminded now of the quote, our deepest fear is not that we are inadequate. Our deepest fear is that we are powerful beyond measure. You are truly powerful beyond measure. You have untapped reservoirs of potential. The being retained by your self-doubt. Think of it this way. You are so powerful that you are the only person who can truly hold yourself back. I ask that you think of one of these doubts you have, patchwork, failing, fear. When we pray together in Cathedral, I want you to hand it back to Christ. He can take care of that for you. You have a journey to get going on. Please stand and pray with me, Cathedral. In the name of the Father, the Son, and the Holy Spirit. Amen. Ever loving Christ, who models for us authentic joyfulness in all things, even in despair. Please take this thing I am offering you in my heart now. Take this burden from me, so I may more fully take on the burden of your cross. Amen. In the name of the Father, Son, and Holy Spirit. Amen. Now please turn towards the flag for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Teachers, please check now for uniforms and lanyards, and please send any students with issues out of student services this week, and continue allowing students in tardy without a pass until about 8 o'clock, because of traffic and issues that we have. Have a great Tuesday, Cathedral.
Okay, so we were just getting finished here with our problem. So we said the sign was opposite over hypotenuse, so that would be negative root 17 over 17, right? And then the cosine is adjacent over hypotenuse, so again, 4 root 17 over 17. And then the tangent, opposite over adjacent, which would be negative 1/4. And then the reciprocals, the sine would be, excuse me, the cosecant would be negative root 17 over 1, which is negative root 17. And secant is root 17 over 4, and cotangent is negative 4 over 1 or negative 4. Okay, so tomorrow that's what you're going to do. Won't take very long, a little half-page deal where I'm going to give you a point. You're going to draw a picture of the triangle formed by that point. So in this case, right 4 down 1, so there's the angle right there, right? And then you just got to know your got to do the Pythagorean theorem to find the missing side, and then know your definitions. Okay? Yeah, Mamuna? Okay, I said I would turn those back in just a moment. Wanted to do this first. Okay? So that's tomorrow. Alright, so now we'll look at the quizzes from yesterday, and then we'll continue taking some notes. These are out of 18. Who has a question about one of the quiz problems? I need to know what quiz number and what problem number. Jackson?
Quiz 3, number 4.
Quiz 3, problem 4. Alright, so quiz 3, problem 4 says find the sine of pi over 6. Okay, now, this is no calculator. So how are we going to find the sine of pi over 6? What do we have to do first? Yeah, we got to figure out how many degrees that is. So pi is 180 divided by 6. So this is a sine of 30, right? Okay, that is not the answer. That is the problem in degrees now. So then what do we do? No, we already did. That's done now, yeah. So now I need to draw my triangle. There's 30 degrees right there. So what do I know about the sides?
30.
Well, it's a 30, 60, 90 triangle. So across from the 30 is 1. 60 is root 3 and the hypotenuse is 2. So there's my triangle. And then I want sine, and sine is opposite over hypotenuse. So the answer would be 1/2, opposite over hypotenuse. Mamuna?
On test 1, at the bottom, number 6 says.
So test or quiz 1, which problem?
Problem 6.
6.
You say to define the cosine. What did you want us to put?
You could put either x over r, or you could put adjacent over hypotenuse. That's how cosine is defined. All right, anybody else have a question about your quiz? Okay. All right. Let's take a look at our notes then.
What was it? Minus 1.5 minus 2. That's 4.
So the 0.5, my son.
Okay.
The 0.5.
All right, so now we are back in our notes.
That's 1.5.
Oh, I know the point.
So we're back in our notes.
I have a question on that quiz.
What? I sit here and waited and
Well,
listened.
you can do
What?
5 minus 5 minus 4. Because you scribbled out that one and that one.
Okay, that is 1, 2.5, 3, 4. So there's 1, that's 2.5, so 2.5.
That's a check on that.
It's wrong.
Oh, well, why is it checked then? Okay.
As opposed to what?
Like the rest of the ones that you marked wrong?
No, why no, it's wrong.
Okay.
Yeah. Okay. All right, we are on page 35, right? Page 35. And we're ready for number 3, which says, tell the sine, S-I-G-N, of the sine, cosine, and tangent. Okay, so what we're doing is you're not filling them out. You're just going to tell me whether they are positive or negative for any angle in this space. Now at first you're thinking, what? But you already know how to do this. Tell me about this. What am I talking about here? Pi over 2 to pi. What's pi again? What's pi over 2 then? So we're looking actually between 90 and 180. We're looking at angles between 90 and 180. And we don't even know what the angle is. We just know it's between 90 and 180. And we just want to know if these things are going to be positive or negative. Remember the practice quiz we just took? How some of the answers were positive and some of them were negative? That depends on which quadrant you're in. right? If things are positive or negative. So we need to talk about which quadrant this is. This is the new part that you may not be aware of. In trigonometry, not when I'm using the compass is a whole different thing, but in straight trigonometry, all measuring starts here. Now that is not the case with the compass, so you've got to set your compass over here. If I were a ship sailing on the seas, I would be using a compass and my labeling would be different. But in mathematics, all angles start measuring here. That's why a moment ago when I drew that 30-degree angle, I drew it right here. That's how I drew it. This, then, if that's 0 and I'm going this way, this would be what? How many degrees? 90. And this would be 180. And this would be 270, right? And then this would be 360 if I went all the way around. So for this problem, we're between 90 and 180. So we are looking at an angle in that quadrant. All this does is tell you which quadrant you're looking in. You're looking between 90 and 180 in that quadrant. Now, I don't know any numbers, any actual numbers, but I do know that whatever this side is, it would be negative. Would you agree with me? Because it's in quadrant 2. And whatever this is, it would be positive, up, and the radius or the hypotenuse is always positive. We talked about that yesterday, that the radius or the hypotenuse will always be a positive number, always. So in this quadrant, your x is negative, your y is positive, and your radius is positive. Here's theta. Tell me about the sign. What's sine again? Opposite over hypotenuse. Well, opposite over hypotenuse would be positive over positive, which is positive. So the sign is positive in that quadrant. Now what about the cosine? Well, cosine is adjacent over hypotenuse. So that would be negative over positive, which is negative. Oh. Try not to lean back against the wall. Okay. And then what about tangent? Tangent is opposite over adjacent, so that would be positive over negative, which is negative. All right, let's try another one. What does pi to 3 pi over 2 mean? Now we're looking at this interval. What is that in degrees? 180. 180 divided by 2 is 90. Times 3 is 270. Everybody get all that? That's 180 divided by 2 times 3. So now I'm looking in quadrant 3 because this is 180 and this is 270. So I'm in here somewhere. Now we know no numbers. We're just looking at pluses and minuses. What do we know about this side? Negative. What do we know about this side? Negative. And the radius or the hypotenuse is always positive. So now we want to know if the sine, cosine, and tangent are positive or negative. So here we go. Sine is opposite over hypotenuse. So that will be negative. Cosine, adjacent over hypotenuse. So that will also be negative. And tangent, opposite over adjacent will be positive. Right? So now you're doing the same thing, only you're doing it with a number. So you need to figure out, I'm gonna go ahead and leave my picture up here. This is 0, 90, 180, 270, okay. And we wanna know about the sine of 152. Now, I know you could type that in on your calculator. That's not what I want you to do. I want you to look at that and without a calculator, tell me if that's gonna be a positive number or a negative number. Okay? So we gotta think about, where is it? Which quadrant would 152 be in? 3? 2. I think it's in 2. Because isn't 152 between 90 and 180? What? So 152 is between 90 and 180, so it's right here. What do we know about these sides? We know this is negative, this is positive, and this is positive, right? We are talking only about sine. So here's your angle. So sine is opposite over hypotenuse. So what about that? Is it positive or negative? Positive. Kids, it's a positive over a positive. Opposite over hypotenuse. It's positive. Cosine 8 pi over 9. Well, it's going to be adjacent over hypotenuse, but I have to figure out where to put it, right? So what might I do? So 180 divided by 9 would be 20, and 20 times 8 is 160. So this is the cosine of 160. Where's 160? Same place. Can I use this same picture? Isn't this the quadrant 2 picture? This time though I want cosine. Cosine is adjacent over hypotenuse. So that would be negative. Now I want to show you something. Remember your definition of cosine is x over r? R is always positive. So the sine, S-I-G-N, of the cosine is going to depend on the sine of x. Does that make sense? This is always positive. R is always positive, so it's not even included in the discussion. But x can be positive or negative. If x is positive, the cosine is positive. If x is negative, the cosine is negative. So clearly, in quadrant 2, your cosine will be negative, because x is negative. All right, what about the tangent of 300? Where's 300? The fourth quadrant. 300 will look like this. We know that, people, because this is 270 and this is 360, and 300 is somewhere in between. So tell me about my sides. What's x? Positive. What's y? Negative. And that's positive. So I want tangent, which is y over x, or opposite over adjacent. So the tangent is going to be negative. Whoa, cosecant 15 pi over 8. Oh, that's a big angle. What's pi divided by, what's pi? 180, right? Pi radians is 180 degrees. Divided by 8. Some of you got this already. 22.5. And then I gotta multiply that by 15. Oh, good grief. Let's see. I got 337.5. Where is 337.5? Well, it's bigger than 270, but less than 360. So isn't it here too? So positive, negative, positive. I want the cosecant. Cosecant is reciprocal of sine. So sine is opposite over hypotenuse. So it'll be hypotenuse over opposite, which will be positive over negative, which is negative. Now the next one, what in the world are we going to do with negative 200? Does anyone have any idea where I'm going to put negative 200? Take a wild guess. Well, no, but you're maybe going in the right direction. The negative angles are this way. Positive goes up and around, negatives go down. So this would be negative 90, and this would be negative 180. So negative 200 is actually in quadrant 2. Because again, we're starting here, always start here. Going this direction is negative, down is negative. So negative 90, negative 180, and then a little bit past that would be negative 200. If you went all the way to here, it would be negative 270. So our sides are negative, positive, positive, right? X is negative, Y is positive. And what did I want? I wanted the cosine. So would the cosine be positive or negative? Negative. I don't know who said that, but you're right. Negative is right. Because cosine is x over r adjacent over hypotenuse. Cosine is x. X is negative. Cosine is negative. Now this one I don't want you to get all carried away with. This is 180 divided by 11, right? Now I know that's not going to go in nicely. That's going to be some weird decimal. But remember, all you're trying to do is figure out where it is. You don't need to know exactly how many degrees it is. You just want to know where to draw it so you can tell if it's positive or negative. So 11 goes into 18 one time, right? Now I can keep going, but I can tell already that this angle is going to be in the teens. Would you agree? And if it's in the teens, where is it? Quadrant 1. I don't need to know exactly what that angle is. I just need to know where it is. And it's smaller than 20, so it's got to be between 0 and 90. Anything in quadrant 1 is automatically going to be positive. Why? There aren't any negatives in quadrant 1, right? Everything is going to be positive. So if you have a quadrant 1 angle, it is going to be, everything's going to be positive. Now, what about this? Where is that? Well, it's more than once around, isn't it? Wouldn't 500 degrees be more than once around? What's once around? 360. So this thing goes all the way around, And how much extra? 140 extra? So it goes all the way around and then another 140. So wouldn't it be in quadrant 2? Remember, this is 90 and this is 180. So if you're going an extra 140, you're over here. We want to know cotangent. Cotangent is, it's adjacent over opposite. So it will be negative. Another way to think about it is it's x over y. X is negative, y is positive. And one more. Cosecant negative, or excuse me, secant negative pi over 7. Well, what's 180 divided by 7? How big of a number is it? We don't care exactly what it is, right? Isn't it 25 point something? Which means it's in which quadrant? Oh wait, it's negative. So which quadrant would it be in? 4. And in quadrant 4, this is positive, but this is negative. And that's positive, of course. So we want the secant. So which sides am I looking at? Hypotenuse and adjacent. And they're both positive. So the secant will be positive. You okay with that? Just try to remember that cosine is associated with x over r, and sine is associated with y. So when you want to know if they're positive or negative, it just really boils down to whether x and y are positive or negative. Okie dokie, Smokies. Evaluate without a calculator. So now we're bumping up a little bit here. Instead of just figuring out if it's positive or negative, we're going to actually figure out the answer. So the first thing we'll do is draw 150. Now I've got a circle drawn there. You don't have to use a circle, but you can. Where is 150? What quadrant? 2? So I'm going to draw my butterfly bow tie in quadrant 2. And this angle is 150. Remember, we start measuring here. We came 150 degrees. That's how we got in quadrant 2, between 90 and 180. Now, here's your triangle, right? You need to tell me, you need to figure out how big your angle is. This is where your logic comes in. Can you figure out how big this angle where my finger is, the angle inside the triangle there? 30. How do we know that's 30? Because all the way to here would be 180, but I stopped here. How much less than 180 did I go? 30 degrees. So this is a 30. Well, is that triangle special? Yeah. Across from the 30 goes 1. Across from the 60 goes root 3, and the hypotenuse is 2. Be careful. Something's got to be negative. Unless I'm in quadrant 1, some number up here is gonna be negative. Is the 2 gonna be negative? No, it is never negative. Is the 1 negative? No, because it's going up. How about the root 3? Is it negative? Yes, because we went left. We're in quadrant 2. X is negative. Now we want the sign. What's the sign gonna be? Opposite over hypotenuse, which, here's your angle. Your angle's always the one at the origin, guys. That's always the angle you look at. So opposite over hypotenuse will be 1/2. And if you typed in sine 150 on your calculator, it would say 1/2. All right. Try to wake up, guys. Everybody's so drowsy. I know I'm the most boring person on the face of the planet, but we got to know this stuff. Tangent negative 240. Step 1, figure out where that even is. Where is negative 240? Now remember, negative means going this way. So that would be 90. That would be 180. That would be 270. So aren't I again in quadrant 2? This angle is 240. Negative. Does that make sense to everybody? You gotta get it in the right spot. So there's my butterfly bow tie triangle. And now this is the angle I have to figure out. This guy right here is the angle I need. Right here. So use your head. You know that this, okay, so this is 0. This is negative 90. This is negative 180. And this is negative 270. We need to figure out how big that blue angle is right there. What do you think? Jacob?
240 minus 180.
Exactly. So what is that?
Oh, shit.
60. You're exactly right. He is exactly right. That's a 60-degree angle. And here's what he thought, I think. He said, look, from here to here is 180. But I went past 180, right? How much past 180 did I go if I went to 240? If I went to 240, I went 60 degrees past my 180 mark, right? Now, if you were thinking, I just want to do 270 minus 240, that's okay, but that gives you this angle. And that isn't the one you want. You need this angle right here inside the triangle. So it's 60 degrees past 180. All right. So what are the sides of the triangle then? If that's a 60, this one is a root 3. This one is a 1, and that's a 2. Biggest mistake that's made in these problems, we forget the negatives. At this point, stop yourself and say, whoa, I'm not in quadrant 1, something is negative. What is negative if I'm not in, if I'm in quadrant 2? What will be negative? The 1 will be negative. Now I want the tangent. Tangent is y over x, or opposite over adjacent. So root 3 over negative 1, which is negative root 3. Tangent 5 pi over 4. How many degrees that is? this weekend.
Oh, yeah. Oh, yeah.
What's 5 pi over 4?
225.
225. So we're finding the tangent of 225. Guys, if you're not sure that's 225, remember how we do that. It's 180 divided by 4 times 5. 180 divided by 4 is 45, and 45 times 5 is 225. So, where is 225? Remember, you start here, and it's positive, so I go up. Isn't it about right here? Because this is 180, and this is 270, and 225 is in between. What's the next step? What do we have to figure out? The angle. We have to figure out this angle right here. So use your common sense. Every problem's going to be done a little bit differently. Think about it. To here is 180, but you went past it, right? How much past it did you go? 45. That's a 45-degree angle. We went 45 degrees past the 180. So what are the sides? 1 root 2. But what did I caution you about? You gotta pay attention to the negatives. Unless you're in quadrant 1, something will be negative. What's negative in this picture? Both the ones, aren't they? Aren't they both negative? In quadrant 3, x and y, both negative. Now we want tangent. The tangent is 1, because it's technically -1 over -1, but that reduces to just 1. Because what's tangent? Opposite over adjacent. There's a lot of steps to these problems, but they aren't too hard. Cosecant 3 pi over 4. Figure out how many degrees that is. Pi is 180 divided by 4. We just did that. Pi divided by 4 is 45. Times 3 is 135. Don't let me pull a fast one on you. Is that right? 135? Okay. Where's 135? Where do I draw this triangle? Which quadrant? Is it in quadrant 1? 2. Very good. Because this is 90 and this is 180, so 135 is in the middle there. Notice, this isn't 135. 135 is the angle that starts measuring over here. That's the 135. You need to figure out this one. How big will that one be? 45? Little hint, maybe you've noticed, but anytime it's a pi over 4 problem, your reference angle is going to be 45, because pi over 4 is 45. So anytime you see a 4 in the denominator here, you know your angle ultimately is going to be 45. Now it could be any quadrant, but it's going to be at 45. So that's going to be 1 root 2. Anything negative? The one on the bottom. Yep, that's your x value. That's negative. Cosecant. Got your triangle here. Cosecant is hypotenuse over opposite. So hypotenuse over opposite will be root 2 over 1, or just root 2. Only 2 more of these. Let's fight through it. You want to try the next one on your own? 7 pi sine 7 pi over 6. See how far you can get with the sine of 7 pi over 6. And might as well try the cotangent of 5 pi over 3. Emmett, pencil to paper. You got it. Elliot, have you figured out 7 pi over 6?
Well, I got 30 over 7.
Well, no, wait. That's 180, right? Divided by 6. So that's how you got 30, right? But it's not 30 divided by 7, it's 30 times. That's a multiply, yeah. So it's 30 times 7. So did you get 210?
Yes.
Okay, so Elliot, it's 180 divided by 6 times 7. Okay? This one's going to be 180 divided by 3 times 5. Okay. So Tessa, where did you put 210? Did you get it drawn? Where? In the third, yeah. 210 would be right about here. That's 210. Because this is 180 and this is 270, so 210 would be in between those, right? Here comes the hardest part. Lauren, were you able to figure out how big this blue angle, that's the key to the whole problem, is that angle right there at the origin. Did you figure out how big that was? How big? 60? What do you think? Is that 60? It's 30. And here's the logic, Lauren. We know that to follow my finger around, all right? This is the angle we're doing. I know that to here is 180, but I went past 180. How much past 180 is 210? It's 30. So that angle is 30. So then you can label the sides. Hopefully you labeled them like that. Oh, we're doing sine. But I'm not ready to do that yet because what do I have to remember at this point? Some negatives. What's negative? 1 and root 3 are negative because you're in quadrant 3, so x and y, adjacent and opposite, will both be negative. And we want the sine. So who got an answer? What did you say? Jacob?
Negative 1/2.
If you said negative 1/2, you are right. The sine is negative 1/2, opposite over hypotenuse. Who has a question about that? Did you break down somewhere? Did you make a mistake somewhere? There's lots of steps.
I knew that angle was 30, but I couldn't remember.
Your angle always goes at the origin. Every angle you mark should be at the origin. All right, how about 5 pi over 3? Rob, did you figure out how many degrees that was? It is 300. And the reason it's 300 is pi is 180 divided by 3 is 60 times 5 is 300. Sean, did you draw 300? Okay, well, wake up, put pencil to paper, and let's draw 300. Quadrant 4, I I heard someone say 300 is in quadrant 4. Now let's make sure that's right. Would you agree that 300 would be in quadrant 4? Yes, because this is 90, this is 180, this is 270, and this is 360 if I go all the way around. So 300 is somewhere in between 270 and 360. So 2 things. Anybody have an issue getting 300? Everybody got 300. Did everybody get it drawn in that quadrant? Then here comes the key piece. This angle right here. Now I want you to think about what you're saying before you say it. How big is that angle? I hear 30s and I hear 60s. It's a 60.
It's the number
Now,
you
again, see, this is where you just have to engage your brain. If you went all the way around, it would be 360, right? We didn't go all the way around. We stopped here. We stopped before we got to 360. How much before 360 did we stop? 60 degrees. Now, those of you that said 30, you're finding this angle right here. This angle would be 30. Is that the angle that I want right here? No. I need the angle in the triangle. 360 minus 300 is 60 degrees. Okay, so my sides are 1, root 3, and 2. I'm not in quadrant 1, so something is negative. What's negative? The root 3. I want the cotangent, adjacent over opposite. So I'll rationalize it and get negative root 3 over 3. Okie dokie, Smokies. Take a look at the next one. Now we're doing, in A, we're doing the sine of 90, and the cosine of 90, and the tangent of 90. We talked about this a little bit yesterday. Can you draw 90 degrees? Where is 90 degrees? Exactly 90. Where would that be? Wouldn't that be right here? Wouldn't this be 90 degrees right here? Can you make a triangle when your angle is on an axis? No. No. So instead, we're going to figure out what the coordinates of this point are. In other words, we're going to find an x value and a y value and an r value, because we're going to have to do y over r, x over r, and y over x. We can't do SOHCAHTOA. There isn't a triangle. There's no hypotenuse. There's no adjacent. We have to use our circular definitions. Now, I have 0 numbers in this problem. I have no idea what any of those things are. So I'm going to make it up. I'm going to let the radius of that circle be 1. This is called the unit circle. And people who work with trigonometry love the unit circle. You could make the radius 5 or root 13. You could make it anything you wanted, but 1 is the easiest number to work with. So I'm just going to arbitrarily say the radius of that circle is 1. If you don't want to use 1, you can use 2 or 5 or 12. I don't care. We're all going to get the same answer. In the end, it won't matter. I'm going to use 1. If my radius is 1, here's the origin. what would be the coordinates of this point up here at 90 degrees? What would be those coordinates? If the radius is 1, if that distance is 1, 0, comma, 1. So x is 0 and y is 1 if I let the radius be 1. So, what's the sine of 90 degrees? Sine is y over r, so y over r is 1. The sine of 90 is 1. What's the cosine of 90? It's 0 over 1, which is 0. What's the tangent of 90? 1 over 0, which is undefined. Very, very good. Very good. Now, let's do the same thing with negative 180. All right, we'll finish this and then I'll shut up, okay? Where is negative 180? Isn't it going to be right here? It's actually in the same spot as positive 180. Wait, this is 0. So if I go negative 180, wouldn't I be right here? If I let my radius be 1 again, what would be the coordinates of this point if the radius is 1? Here's the origin. Negative 1 comma 0. The radius of the circle is 1, so I'm taking 1 step to the left. That would be negative 1, 0. So x is negative 1, y is 0, and r is 1. So what is the sine of negative 180? 0 over 1, which is 0. What is the cosine of negative 180? Oh, cosine. X over r, negative 1 over 1, which is negative 1. And the tangent of negative 180, y over x, which is 0 over negative 1, or 0. So we don't have any undefineds for that one. All right, well, that's good work. Remember, we have that little half-page quiz tomorrow. Wait, do I see you tomorrow?
No.
No, I don't see you until Thursday. So yeah, your quiz is going to be Thursday.